Okay, we just received this worksheet, and we're going to have to find a way, actually, to go over things and try to. I'm going to try to anticipate problems, and I'm thinking this worksheet's probably going to be a problem for people because they won't know how to get started on it. So let's try to take care of that in this video. Let's take just look at a real simple problem to get started with, and because these are titration problems, and they involve the stoichiometry, and they also involved like acid-base titrations. So we'll make an answer key. Now remember, this answer key is going to be released on Friday, and to get the full benefit of this worksheet, you definitely need to try to do these problems before Friday, because more of them are coming and they're going to start piling up. So I'm not taking this one for a grade. Now, that doesn't mean you shouldn't do it. It just means that you are going to, it's going to be necessary for you to, do these problems. So we're going to do a key on this one. Whoops, not 2000, 2020. So we'll go over a couple of these to get you started on them. Once you see how one is done, you can probably do the rest of them. They're really not that hard to do. And we'll do an easy one, number 3, to get started. All right, so on this one, we have an active ingredient, aspirin, and that's acetylsalicylic acid, and they gave the formula for that. They talk about the nature of aspirin, how that active ingredient is mixed with binding agents and fillers to make the aspirin. I mean, the whole aspirin tablet isn't acetylsalicylic acid. It's just a little bit mixed with things like, I don't know, starch or some kind of, I don't know what they use for binders, but the rest of the pill is just kind of like some inert thing that you just, makes the bulk of the pill. So they're going to dissolve this in water, and then they're going to titrate it. Now, this is the titration information here. And what they're actually doing, yeah, that's good, blue base, right? So what they're doing is a titration. So they're going to use sodium hydroxide, and they're going to put it into the burette, and they're going to measure, well, they know the concentration, this is like the known in the titration. So that's 0.128 molar sodium hydroxide. And they're going to put the acid down here, which is the aspirin, acetylsalicylic acid, and they're going to titrate this until they get to the end point. Now, if you remember, they're going to add just the right amount of sodium hydroxide. So every drop of sodium hydroxide that's added neutralizes a drop of acid. And what they're going to do, if you remember from the titration days, they keep on adding this dropwise until the acid actually turns pink. And once the acid turns pink, then they'll have neutralized every drop of acid with an equivalent amount of base. So that's actually called the equivalence point. That's his equivalence point. Oh, I'm sorry. You might be hearing something below here. And I was just going to say, that's my dog. We're at the home studios here. And she is actually very annoying at times. And right now she's squeaking on her Bumble. So please ignore her. You will hear probably interrupt like she is prone to do. So we're just going to have to ignore her for a bit. All right, back to the task on hand. So we're going to take, this took 14.10 milliliters of this strength of base to neutralize the acid. Well, we can't actually measure, this isn't comparable. The volume isn't comparable. And the grams of acetylsalicylic acid is what we're really looking for, mass. So that's not really comparable. So what we need to do is we got to get it into a comparable unit, moles. Because at the equivalence point, the moles of acid equals the moles of base. And if you remember, whenever we have the two pieces of information, we need to calculate moles. If we know the molarity, which is moles per liter, and the volume, right, moles per liter times liter, we end up with just moles. So this formula sometimes is used to solve titration problems. So the molarity times the volume is the number of moles. So the moles of acid equals the moles of base. So we can use M1V1 equals M2V2 as a shortcut to actually answering a lot of these problems. But I'm not going to do it that way. I'm going to actually do it using just acid-base stoichiometry. All right, so that's the idea. We're going to titrate this to find out, we're going to try to find out how many grams, X grams, of the acid is present inside this original tablet that we dissolved. So the first thing we need to do is realize that titrations are neutralization reactions. So we're going to take the acid, write down this formula, acetylsalicylic acid, and we're going to react it with sodium hydroxide. Now this is a neutralization reaction. Do not write this as an equilibrium. Neutralization reactions are always, they never form equilibrium. They're actually going to be going to what we say go to completion. So they're just take the form of a double replacement reaction. So these two ions are going to get together, sodium ion and C9H7O4, and we're going to form water. So this is going to be the products of every neutralization reaction between an acid and base. We're going to have a neutral salt and we're going to have neutral water. All right, it's balanced, which is great. So we have the balance equation. Now, we have all the pieces of information that we need. We have the starting point is the 14.10 milliliters. All right, so this is just like a stoichiometry problem for the most part. You don't always have to do it this way, but I think this is like the easiest way to set it up. So 14.10 milliliters, 1 liter is 1,000 milliliter. Okay, now this is the volume. Now we're going to have to change it to liters, right, because this is moles per liter, right, not per milliliter. And then we're going to multiply the volume times the molarity. So the molarity on this one, 0.128 moles of sodium hydroxide in 1 liter of sodium hydroxide. This whole thing is going to give you, let's change the color here, this gives you the number of moles of sodium hydroxide. So whatever this is, whatever the answer for this is, it's going to be the same as the number of moles of acid we had in there because we actually hit the equivalence point. Oh, and by the way, there's another term that's sometimes used, equivalence point. Sometimes the term is end point. And sometimes these are used like they're used interchangeably as if they mean the same thing, and they sort of do. But the endpoint is visually what you see, all right? So the endpoint of the titration is the point when the color change occurs inside the beaker. But the equivalence point is something we can't see, but we assume that is occurring close to the endpoint. And the better the better the acid-base indicator, the more agreement there is between the endpoint and the equivalence point. What we really want to know is the point where the number of moles of acid is equal to the number of moles of base. We can't really see that, so we use the indicator, like phenolphthalein is what we use in our titrations, to come up with what the end point would be. The end point gives us an idea that we're near or at the equivalence point. Of course, that's an assumption, and there's always going to be some error, but that's what we're doing. Okay, so we're here. So we can use the balance equation now because we have mole ratios, right? Because this balance equation, this neutralization reaction, 1 mole of sodium hydroxide right here is equivalent to 1 mole C9H7O4. All right. And look where we ended up, our string of conversion factors, we ended up with moles of sodium hydroxide. Let me move this over. It's getting kind of crowded over here. So we're at moles. All we have to do to get to the mass, which is number of grams, is to change that. 1 mole is going to be equal to, and I calculated this. This is off the periodic table. And that's it. We have the entire thing, right? So this is our setup, and this is just no different than any other setup we've ever done. So we just have to go through 14.10 divide by 1,000. Of course, this part you could probably do in your head, but I'm showing it here just to make everything make sense here. So we're going to take this and change it to liters by dividing by the conversion factor. 1 liter is 1,000 milliliters. Change that into, so 14.10 divided by 1,000 multiplied by 0.128. We're going to change moles of sodium hydroxide into moles of acetic salicylic acid. And we're just going to use the balance equation right here. So that's ratio is 1 to 1. And then we're going to change the moles of this to grams of this. And when you actually all said and is done, you should have arrived at 0.325 grams of acetyl salicylic acid. So HC9H7O4. And that's our final answer. That answers the question. So these are acid-base titrations. Not every problem on here is going to be exactly this way. This one's kind of unique because we're going to solve to number of grams. We're not actually trying to determine the molarity of the unknown. We could certainly do that. But this is how you do, like, this is like one of the ways you set up the problems. They all have one thing in common, that they're going to be based on some type of titration, and which is a neutralization reaction. And remember, neutralization reactions go 100% to their products. So when a neutralization reaction is done, we're assuming that we have 0% of this and 100% of that. When everything is done. And it's called a neutralization reaction because we have neutral water, pH 7, and a salt, which is generally going to be neutral. This one probably would be a little basic because the sodium ions in spectator, that's not going to affect the pH of the solution, but this is actually going to react with water. So I would imagine that the negative ion would be slightly basic, although it's called neutralization because we assume a neutral salt. All right, so that's how you do like an easy one. That should get you started on doing these worksheets. Remember, this worksheet's going to be it's going to be given out on Friday. That's 3:20. Whoops, not 3:30. 3:20. And that's when the answer key is going to be given out. Now, this is an optional. I'm not collecting it for a grade. Not this one to begin with. That doesn't mean you shouldn't do it. It's very important for you to be trying these problems before you look at the answers. And if I actually, well, let's just put it this way. You're all at that stage where you know that the homework isn't really just for a grade. It's actually for you to practice these problems so you can get good at them. So make sure you do the problems before Friday so we can move on into the next type of problem. So we can continue on with the class, even though we're not being able to meet. Okay, well, I'm going to end it here. I don't want this video to be too long, but I do want it to be thorough. This is how you do question number 3. I think I'll take a look. If you have a question on one that you'd like to see done or have a explanation similar way, just let me know. I can go over any one of those. I would imagine question number 7, because in question 7 you have to do a mixture of 2 different bases, which can complicate things. Makes the math a little bit more tricky to do, and so I would imagine question number 7 is going to be requested. I'll probably just work on a video for question 7. Okay, well, I got to sign off here. I'm not exactly certain how to end a video. I don't want this to continue on unnecessarily. So for right now, signing off from the home studio. Have a good day. Auf Wiedersehen, au revoir, and however you say goodbye in Spanish. All right? Have a good day.